So we looked at factoring our trinomials today. Very, very similar to factoring by grouping, but there's one step right before that. So this is going to round out our factoring techniques that we're going to have for our unit. So we have greatest common factor. We should always be looking for this one. It may not be in any of our problems, but we always need to check for it at the beginning, in the middle, at the end of our problems. Just constantly looking for greatest common factors. Grouping, remember that's when we had our four terms. And the AC method is pretty much everything else. So if you can't do greatest common factor, you can't do grouping, you've got to check to see if you can do the AC method. And then once we've exhausted all of these methods, the most likely the polynomial we're looking at cannot be factored. So the steps to the AC method, let me move myself a little bit right here. So it starts off with the trinomials. They're always written as ax squared plus bx plus c when we have it in order from biggest power to smallest power. And this is where it gets its name of AC method. We take a, we multiply c. That's going to give us a number. We then find the factors of a and c that happen to add to our middle term, b. Once we know what those factors are, we split b based on those two factors. And when we split it, that gives us four terms, and we'll factor it by grouping. So let's take a look at a few examples. X squared plus 11x plus 18. So we check for the greatest common factor, and there isn't one. Nothing goes into x squared, 11x, and 18. So we're going to take a, which is 1. We're going to multiply 18, which is 18. And now we're going to find all of our factors that multiply to 18. So we have 1 times 18, we have 2 times 9, and we have 3 times 6. This pair of numbers, when combined, make 11. So we have x squared plus 2x plus 9x plus 18. So we've split that 11 into two separate terms, the 2 and the 9. Because we've separated them into two different terms, we've actually created four terms, which lets us factor by grouping. X squared plus 2x, so we have x comes out, leaving us x plus 2. The second one, 9 comes out, so we're left with x plus 2. And last but not least, with factoring by grouping, the x and the 9 go together, and then I write one of my x plus 2's in my answer. Let's try it again. This time we'll have a negative in place, so we're going to have to deal with that a little bit. So we're going to take 1 times 50. That's 50. Well, I skipped a step. Check for greatest common factor. 15 and 50 share a 5, but the x squared doesn't, so we cannot take it out. So that's when we can move on. So I have 1 times 50, I have 2 times 25, I have 3 doesn't work, 4 doesn't work, 5, and 10 is the last one. None of these right now combine to give me negative 15. However, if I make this a negative 5 and a negative 10, they combine to negative 15, but when they multiply, there's still a plus 50. So there's the two that we need. So we get x squared minus 5x minus 10x plus 50. If you're wondering, does it matter the order where we put the 5 and the 10 in the middle? It does not. We could have put the negative 10 and the negative 5. They could have switched places. Doesn't matter. We're going to take out that x in the first one. So I need this to become an x minus 5 polynomial. So when I take out 10, that's not enough because now my signs are wrong. So I'm actually going to make sure I take out a negative 10. And that negative 10 switches the signs. Now we have our identical binomials. We have x minus 10, x minus 5. All right. Now we have our negative on our C term. So again, we check for greatest common factor. We don't have one, so we're going to take the 1 times the negative 12 and get negative 12. 1 times 12, 2 times 6, 3 times 4. Technically, none of these are actually the factors because I would need like negative 1, negative 2, negative 3. So that means we'd also have 1 times negative 12, 2 times negative 6. Whoops. And 3 times negative 4. So here's all the factors that work. It's this one right here that combines to our positive 4. So we're going to take x squared minus 2x plus 6x minus 12. Again, these could be flip-flopped, and we still get the same answer. Factor our first two terms. Take a 6 from the second two terms. And we have x plus 6, x minus 2. Last problem we're going to look at is what happens if they have not a 1 in front. So we got this 2 right here. We would approach this problem the exact same way. We would take 2 times negative 108, and we get negative 216. We would then have to find the factors that multiply to negative 216 that combine to 6. After some trial and error, you would find that it's negative 12 and 18. But here's the importance of the greatest common factor. The greatest common factor is 2 in this problem. So if we take the 2 out, we're left with this trinomial. And instead of trying to find my factors for 216, I now have to find the factors for negative 54. A lot more pleasing, in my opinion. So the two numbers that multiply to negative 54 that combine to 3 are 9 and negative 6. This 2 that we took out, he's just going to chill on the left side of this problem. He's not going to go anywhere. So it's as if he doesn't even exist. So we have x squared plus 9x minus 6x minus 54. From the first two terms here, I can take an x. 2 still chilling. Second two terms, I'm going to take a negative 6. That way I can get the x plus 9. And then in the end, we have 2, x minus 6, x plus 9. And there's our answer. Notice that the 2, once we took it out, he never played a factor in the problem. He just chills on this left side all the way through. If we forgot to take out the 2 at the beginning, at the end of our problem, we would have had something like this. 2x minus 12 and x plus 9. Or we would have had 2x plus 18 and x minus 6. So that 2 is kind of lurking within the problem. So that 2 is currently right there, or it's right here. And our problems have to be fully factored. So if we forgot to take the greatest common factor out at the beginning, we would have to take it out at the end. So we take the 2 out, and we'd have our answer that was like this. Or if we took the 2 out of this one, The only difference between the answer we got and this one is the order of the binomials, which we know already does not matter. That's factoring by the AC method.